Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole.
And I'm Brian, and we're both from Calgary, Alberta, Canada.
Thanks again to our Patreon subscribers. We really appreciate your support for our show. This show does take a lot of effort to get it together every week, and we really appreciate those of you who've taken the time out of your day to sign up for our Patreon and take advantage of our bonus content.
If you were wondering how much it costs if you're not subscribed to Patreon, it's less than the cost of a fancy cup of coffee at Starbucks or your local coffee shop. $5 a month, you get to hear us talk about more interesting engineering failures. You get a Failurology episode every week. Failurology 1 week. Next week, you get a mini Failurology episode.
And that's $5 Canadian, which our dollar is not doing great right now. Also, interestingly enough, like we've talked about so many times, we have a very long list of failures that we want to talk about on the show, a list that honestly never gets shorter. And sometimes there's a failure that, just from what we know about it, we think that we have a lot of information. And so we want to use it for a regular episode. And then once we start digging into the research, we find that not a lot of the information we need is publicly available. And so we decide to use it for a mini failure. Or like today's episode, I, looking into this FedEx Express Flight 80, thought that this was going to be a relatively simple failure and there wasn't going to be a lot of data on it. And as I dug into it, I realized there was a ton of information, and we decided to do this for a regular episode. So we definitely flip topics back and forth, failures back and forth between the two, depending on what kind of information we can find. Please head on over to Patreon, support our show. There's a link in the show notes, $5 Canadian a month. We really appreciate your support.
This week in engineering news, electrical vehicles pass the remote road test. As I'm sure many of you are aware, electrical vehicles don't really have the same kind of range that we expect out of our normal internal combustion engine vehicles. Whenever we drive around, we expect there's a gas station every block, every other block, every 3 or 4 blocks. And if we go on a longer trip, there's a gas station in pretty much every town you go through. Electrical vehicles don't quite have that level of infrastructure yet. So it's important that electrical vehicles, if they're going to become a thing that everyone has or most people have access to, they need to have some testing done on remote road tests. And a number of manufacturers decided to do that in Australia, which is a fairly sparsely populated country. In the interior part of Australia, there's not a lot of people. Australia is very hot, it's very remote, the roads are fairly rugged, so this is a great test location for remote road testing for electrical vehicles. So this test was conducted by the Australian National University, and roughly 93% of residents in Australia can travel to essential services with even the lower range of electrical vehicles on the market, even people living in remote areas, without needing to recharge them en route, which makes a lot of sense. Like I mentioned, Australia is not very heavily populated. There's a lot of their cities are on the coast, so you can do a lot of your shopping and your errand running and your kind of your day-to-day activities just within the city. Or if you live outside of the city, it's not a super extraneous trip to come into the city and then back to where you live to grab things, which I think is probably common for a lot of people, no matter where in the world you live. Most of your life kind of centers around the same 10 or 20 mile radius of where you live. And what the researchers found at the Australian National University was that using electrical vehicles in remote areas is more feasible than what they expected. So currently, for remote communities, a lot of things are powered there by diesel. So diesel generators will power a lot of electricity needs. Their trucks and their vehicles and their cars are filled with diesel. Their side-by-sides, their ATVs, those are all filled with diesel fuel. And that's the common fuel choice in Australia. It's a common fuel choice here in Canada and a lot of northern communities. I'm sure it's the same in the USA for fairly remote communities. There's a lot of diesel usage that occurs in smaller remote areas. One of the advantages, though, for electrical engines, they are a lot simpler to power if you can solve the issue of recharging them or having adequate range for people to conduct their day-to-day life things in remote communities. One thing this study is looking to unpack is the impact of unsealed or unpaved roads on electrical vehicles. So these are roads that don't have an asphalt surface or a concrete surface. So they're going to be gravel roads that don't have any sort of sealing compound on top of them. We're fairly confident in knowing how internal combustion engines will function on gravel roads. There's going to be some reduction in fuel capacity. So the researchers still need to figure out what impact this has on the range of electrical vehicles and just overall the impact that it has on electrical vehicles. Because a lot of the power packs for electrical vehicles, the battery packs, they're underneath the car. There's also a couple other things they wanted to look at. So they need to obviously look into the weather impacts on electrical vehicles. So in Australia, obviously the heat is a big thing that they want to look at. Other countries, the impact of cold weather is obviously more important. As the weather gets colder here in Canada, the range of electrical vehicles drops, and I believe they probably take a little bit longer to charge, overnight, just with having to also use some of the power that they're charging from, just to keep a lot of the battery packs and the systems warm at an operating temperature.
I think electric vehicles, the more heating and or air conditioning that you're using in your vehicle while you're driving it also reduces the charge on the battery. So the more creature comforts you need to use and or safeties in place to protect the battery life, those are all taking away from the charge you can use to drive further.
Yeah, so hopefully over time, a lot of these issues are solved. I don't think with the electrical vehicles that you're ever going to not be able to really use the battery to kind of heat the battery or to power some cabin systems for heating or air conditioning, depending on the climate there. But over time, I think and I hope that a lot of these battery issues that we see right now, or range related issues, they do become mitigated or solved. I remember when electrical vehicles really started being talked about, I'm going to say about 20 years ago, or at least that's when I first started hearing about them. Their range was very limited, kind of 25 to 50 kilometers. The battery technology just wasn't there for battery power or endurance to power cars to a significant level. So there's been significant strides that have happened in the last 10, 15, 20 years in terms of electrical vehicles and also battery technology, and electrical vehicles coming to more mainstream manufacturers, becoming more of a flagship product that manufacturers use instead of just something in addition to internal combustion vehicles that they currently offer. So overall, the transport sector currently accounts for about 25% of global emissions and more than 18% of Australia's greenhouse gas pollution. With the addition of electric cars or electric vehicles, as more and more people have them, we should see a drop-off in global emissions and greenhouse gas emissions, for countries that have significant uptake on their electrical vehicle usage.
Fun fact, unrelated to electrical cars, but related to the statement on global emissions, the built environment, which is essentially cities or urban areas, buildings, and other infrastructure, that accounts for nearly half of global CO2 emissions. Of that half, or 50%, building operations account for about 27%, and then building materials and construction are another roughly 20%. And those are some pretty big numbers. But if I've learned anything from 14 years working with buildings, specifically mechanical systems, they're rarely operated as optimally as possible, and there's always room for improvement. If you want to read more on the electrical vehicle road test study in Australia, check out the link on the webpage for this episode at failureology.ca. Hey Brian, what's the first thing you think of when people approach you on the street?
Well, mostly the Audacity.
Isn't that an audio recording program?
It is, but they don't sponsor this podcast. If they did, though, this week's episode of Failureology would be brought to you by Audacity. Now, on to this week's engineering failure. FedEx Express Flight 80. This was an MD-11 that crashed rather hard in Japan in 2009. FedEx Express Flight 80 was a scheduled cargo flight from Guangzhou Baiyan International Airport in China to Narita International Airport near Tokyo, Japan. It's a flight distance of roughly 2,900 kilometers, or just over 1,550 nautical miles, since this is an aviation episode. So the crash, like I mentioned, it occurred March the 23rd, 2009. The aircraft that was involved in this incident was a McDonnell Douglas MD-11, and the MD-11 is similar to an aircraft that we've talked about on a previous episode of Failureology. And that was the episode where we talked about United Flight 232, which suffered a fan blade separation in flight that severed all three of the hydraulic control lines that ran through the tail section of the aircraft. and they had to use the throttles from engine number 1 and engine number 3 to control all of their flight handling, since they didn't have any hydraulic controls for ailerons or elevators or rudder on that airplane. So the MD-11, it's kind of the evolution of the DC-10. So the MD-11, it was a much extended version of the DC-10. Instead of having a flight crew of 3, it has a flight crew of 2, and that was thanks to glass cockpit displays. So a lot of the systems that we talked about before that the flight engineer would be responsible for, that was all taken over by a lot of automation and then just displayed to the pilot displays in the front. In addition, the MD-11, it does have winglets. So those are like the little pieces that stick up at the end of the wings. And so they saw about a 2.5% fuel saving overall. There was significant use of carbon fiber throughout the MD-11. So it was just really a modernization and an extension of the DC-10 that we've talked about on previous episodes. So the defining characteristic for it would be that it has 3 engines, so 1 under each wing and 1 engine in the tail. That said, though, today's episode is about FedEx Express Flight 80, which, as I mentioned, is a similar model of airplane, but these are significantly different failures, which we'll see how they're significantly different in about 5 minutes here. The very first MD-11, it flew on January the 10th, 1990, and it entered into service on December 20th of that year. So this is, like I said, it's a much more modern airplane. The DC-10 was kind of in the late 60s, early 70s was when that came into production and usage. So this is a much more updated version of this airplane. It's kind of like having a Honda Civic from 1980, and then you have a Honda Civic that you buy in 2018. So it's still kind of the same name. It's still got the same features, or still kind of has the same shape, but the features are a lot different between the two vehicles.
Great comparison, Brian. I used to own a 2007 Honda Civic, and now I own a 2019 Honda Civic. And I completely understand what you're saying, because it's the same car, but it's not the same car. For example,
Yeah.
my '07 was naturally aspirated, which meant just normal engine, no supercharger, no turbocharger. And the new models have a smaller engine volume, but now it's turbocharged, and there was definitely a lag that took me a hot minute to get used to. We're good friends now, though.
Yeah, I had the same experience. I used to have a 1999 Volvo S70 sedan, and it hit about 400,000 kilometers, and I decided that was a lot of kilometers. I should get a different vehicle. So then I bought a used 2019 Volvo XC60. Technology changed a lot in the 20 years since the 1999 came out, and I had upgraded my 1999. It had a backup camera, it had a dash cam in there, and it had nice lights in the interior, but the overall technology and the handling, and like Nicole mentioned, kind of the engine sizes and capacities, they've changed significantly in 20 years. But overall, though, it was a good upgrade for going from 1999 to 2019.
Yes, the DC-10 to the MD-11, maybe not as good of an upgrade based on what we're going to talk about today.
So this specific MD-11 that we're going to talk about, it's actually got a really cool history, and it doesn't really have a lot of relevance to this episode, but I still think it's really cool. So it was built in 1994, so kind of 4 years after it was first introduced into service. The MD-11 series was introduced into service. But this aircraft, it was used by NASA as a test bed for their propulsion-controlled aircraft systems in 1995. Then it went over to Delta, where it was part of Delta's fleet from 1996 to 2004. And then it was sold over to FedEx in 2004. And then interestingly, by 2009, FedEx was the largest operator of the MD-11 series. And today, half of them that are still in service are flying for FedEx. So the production run for the MD-11, there were only about 200 aircraft produced in the MD-11 production run. It was kind of an ill-advised aircraft, I think, overall. The need for 3-engine aircraft really started to decline. I'm going to say in the mid-90s to the early 2000s. Just the engine technology got a lot better. Extended twin-engine operations just became a thing for regulatory bodies. So there wasn't a need to have three-engine aircraft, and they really started to really get phased out of service, except for kind of freight operations. So the 3-engine aircraft that are left flying, it's really just the DC-10 and the MD-11 are the two 3-engine aircraft that are commonly flying, I'm going to say, within North America. There are other examples that continue to fly in other countries around the world, but if you see a 3-engine aircraft operating in North America, it will likely be an MD-11 or the DC-10.
I think too important to that is that if I remember correctly, the MD-11 came out shortly before McDonnell Douglas was acquired by Boeing. And so I think after that acquisition, there was a much greater focus on Boeing's line of aircraft as opposed to sticking with what McDonnell Douglas had been doing, especially with the potential risks of the third engine on these planes, which we talked about in United Flight 232, which I believe was episode 42.
Yeah. So once once McDonnell Douglas and Boeing merged, there's a lot less emphasis on the McDonnell Douglas fleet series of stuff. There were a couple airplanes that McDonnell Douglas had in development that just got renamed as Boeing aircraft, and then certainly with the MD-11 and DC-10 series, that was pretty much the end of the line for anything that was designed by McDonnell Douglas for a wide body aircraft, and Boeing just kind of went with a lot of their own aircraft.
So on to the crash of FedEx Express Flight 80. The accident happened at 6:48 in the morning on March 23rd, 2009, while they were attempting to land on runway 34L in Japan. The weather at the time was clear but turbulent. The wind direction was consistent to the west, but the intensity varied a lot. It swung about 15 knots faster or slower than normal wind speed, and it just kept kind of bouncing around, which I think made it really, really tricky for them to land because they would get a pocket of strong wind and then that wind speed would drop. And, they've put inputs into the plane to counter that strong wind that's no longer there. And I think that just made it really, really tricky amongst the other issues that the plane had. Both pilots had extensive experience. Captain Kevin Kyle Mosley was 54. He was from Hillsboro, Oregon, and he was a former U.S. Marine Corps pilot. He had been with FedEx for 13 years, and he had more than 12,800 flight hours total and over 3,600 hours on the MD-11 specifically. And then First Officer Anthony Stephen Pino was 49 from San Antonio, Texas, and he was a pilot in the U.S. Air Force. He'd been with FedEx for 3 years, with over 6,000 flight hours total and almost 900 hours on the MD-11 specifically. The planes that had come into that airport just before Flight 80 reported wind shear at an altitude of under 600 meters, information that was then relayed to the FedEx air crew, so they knew that coming in. And the surface winds at the time were reported at 26 knots with gusts up to 40 knots. To counter these unstable wind speeds, Captain Mosley decided to land the plane with an approach speed 10 knots faster than normal to overcome the unstable headwind and avoid dangerous loss or lift.
Which is a very common thing. I mean, every approach in gusty conditions like this, you definitely add on that 10 knots of approach speed.
I will add that the recommended landing airspeed for the MD-11 was already faster than comparable airplanes. So then to add 10 knots on top of that, it starts to snowball. And I think that's one of the factors that led to this, but we're going to get into that. But as they came into land, their airspeed fell from 178 knots to 154 over about 35 meters of elevation. The plane was sinking too rapidly, and First Officer Pino tried to counter by pulling the nose up to gain lift and slow their rate of descent. When he pulled up, the high angle of attack caused their speed to drop even more, so he pushed the nose down again. He needed to increase thrust to maintain the approach speed, but unfortunately he didn't.
To make matters worse in this situation, the auto throttles that are used on the MD-11, they automatically entered what's known as a retard stage and began slowing down the engines for landing. So the auto throttles just come all the way back. They reduce the engine power. So Pino should have restored manual power, but was too busy trying to control the plane that he didn't manage to do that either. So I believe the recommendation for DC-10 and MD-11 series in this situation is to pitch the nose up. I believe it's to 7.5 degrees and then apply power in a situation like this. So Pino pulled on the controls to flare the plane for landing, which is just bringing the nose up a little bit, but he did it a bit too late and a bit too sharply. And realizing the nose was too high, he pushed the nose back down again. So this is something that's taught in initial flight training. It's basically what not to do. As he's raising the nose and he realizes it's too high, it should have been an application of power. So it's in a slow flight regime right now. So pushing the nose down is not the right course of action here. So After the plane hits the ground for the first time, the plane destabilizes and it doesn't really recover from this bounced landing, which causes structural failure of the landing gear and the airframe. So when it landed, it bounced 3 more times before coming down on its nose. And so this action kind of rapid pitching up and down, it's known as porpoising. So if you can just kind of imagine a dolphin, going through the ocean as they kind of, jump out of the water and back down. That's really what the airplane's doing as it goes down the runway. So obviously, this is not a great situation for any sort of directional control. So a loss of directional control and a loss of altitude control. When the gear failed, eventually the left wing struck the ground and the plane veered to the left. So the left landing gear, it rips through the wing, so it punches up through the wing, snapping it in half. And as the right wing generated lift, it rolled the plane over to the left. So this is not a good situation. So on their approach, they're having, they're dealing with gusty conditions. They've added on 10 knots to their approach speed, which is fine. But as they get into kind of one of the critical phases of flight, as they're flaring to land, so they're 50 feet or less off the ground, things start to go not very well for this airplane, and it does porp as it bounces down the runway. The correction procedure was not applied correctly, and unfortunately this winds up with the left main landing gear punching through the wing and separating that wing. So as a result of this, as we've talked about before, airplanes store fuel in their wings and in the belly tanks usually. So as the landing gear punches through the wing, the fuel tanks tore open and a massive fireball erupts. So in full view of all of the passengers waiting in the terminal for their flight. So that's not a good spot to have a giant fireball happen. It's bad enough that all these people saw your terrible landing. I've certainly had some bad landings. I've thunked it on a number of times. But yeah, to have a fireball and this airplane crash in front of the terminal building, not really ideal circumstances.
All things aside, I think the people watching them was the least of their concerns. They just ripped the plane apart and lit it on fire. Also, because this happened in view of the terminal building, the landing was caught on video. And we will provide a link to the video in the sources for this episode, which can be found on this episode's webpage at failurology.ca.
Well, the MD-11, it finally stops off the side of the runway. At this point, it's inverted, it's on fire, it's not on the runway. The air traffic control guys in the tower, they activated the crash alarm, and the fire trucks were at the plane in less than a minute, which is a great thing to have. Unfortunately, it took the fire crews 2 hours to extinguish the entire blaze, and by the time they were able to reach the cockpit an hour later, both the captain and the first officer, who were the only people on board, because remember this was a cargo flight, they had unfortunately perished. Captain Mosley died of major injuries sustained during impact, and First Officer Pino died from smoke inhalation shortly after. This was the first fatal aircraft accident in FedEx's history.
So just going back to what I was saying earlier about how some failures jump from regular to mini failure or vice versa, everything that we've talked about so far is information that we knew coming into this, which is why I had initially thought this would make a great mini failure episode. What I didn't realize until I started digging into the MD-11 is that it had a number of issues, and it also had a number of accidents that took place. And so we're going to talk about all of those and kind of recap those now. And I think this speaks a lot to the issues that happened on that day in 2009 in Japan. This definitely wasn't the first MD-11 that bounced on landing, flipped over, and burned. In fact, 12 years earlier in 1997, FedEx Express Flight 14 had a very similar accident in Newark, New Jersey. After the Newark crash, the Federal Aviation Administration required all MD-11 operators to be trained in a newly developed bounce recovery technique. And that's the recovery technique that Brian was talking about earlier. And this technique required pilots to increase engine thrust and hold a positive pitch angle when they recognized a bounce, which just prevents the plane from porpoising or bouncing up and down continuously, allowing the plane to float down the runway until it can land smoothly. Both Captain Mosley and First Officer Pino received bounce recovery training in 2006. When the Japan Transport Safety Board investigated the crash and came to an interesting realization that Pino probably never even knew the plane was bouncing. So the MD-11's cockpit was unusually far forward for the center of gravity of the plane, and because of this, you couldn't always tell from the front of the plane what the back was doing. It's completely plausible that neither the captain nor the first officer had any idea that the plane was bouncing at the time. The plane's data recorder did register an increase in engine thrust and pitch just before the third touchdown or the final bounce, suggesting an attempt at a bounce recovery maneuver, when they ultimately did realize that it was bouncing, but unfortunately by then it was too late.
So it's believed that sleep, or more specifically lack of sleep, might have played a factor in this crash. So Captain Mosley is believed to have had only about 4 hours of sleep the day before the crash, and First Officer Pino even less than that. So remember, this flight, when it was landing, it was 7 a.m. in Japan, and it was an overnight flight that left at 9:44 the night before. And in fact, about 45 minutes before the crash, the cockpit voice recorder that was installed in the MD-11 captured the flight crew joking about being tired. Investigators also noted that while First Officer Pino had several hours on the MD-11, most of those were as a relief pilot, or the pilot that takes over in the middle of long-haul flights. And it's a very common thing that basically everyone does as part of long-haul flights. You have a third pilot in a cockpit that kind of trades shifts out with the flight crew, so that way the flight crews can have some rest, but there's always two people at the controls of the airplane. Also interesting to note, First Officer Pino's flying schedule only allowed for 2.5 landings per month, so he doesn't have a lot of landings for each month that he's been operating this aircraft. There's also another similar crash to Flight 80 in the Newark crash that Nicole mentioned, and this is in 1999. The China Airlines Flight 642 that crashed while landing in Hong Kong during Typhoon Sam. Now, to be fair to the MD-11, the crosswinds at the time of the landing in the China Airlines Flight 642, they did exceed the design limitations for the MD-11. The plane did flip onto its back and caught on fire, and luckily only 3 passengers were killed.
But these weren't the only issues with the MD-11. McDonnell Douglas, as we talked about, had promised fuel efficiency when the plane entered service in 1990. But that was a myth, and the range was actually 500 miles less than expected. They tried to improve fuel efficiency by shifting the plane's center of gravity further back or aft than other commercial aircraft. They also installed a fuel ballast tank in the horizontal stabilizer to improve fuel efficiency, but this inhibited crosswind performance, as we've seen with the failures that we just talked about.
This was corrected in 1993 with fuel consumption optimization software, but it was too late to save the MD-11's reputation. And this is one of the reasons that only about 200 MD-11s were built, which is not a lot of airplanes in a production run. Operators also found the planes difficult to fly, and it was noted that it was hard to override autopilot, and when the pitch became unstable in flight, the planes would buck wildly up and down for several minutes before getting control again. Again, not something that you want happening to your airplanes in flight. Additionally, it was very easy to deploy the slats in cruise flight by accident. So slats are used on aircraft in typically for takeoff or landing, just to increase lift on the wing. It's not something that you want coming out while you're in cruise flight. That's not the flight regime and profile that they're designed for. So in 1993, China Eastern Airlines Flight 583 went into severe oscillations from accidental slat deployment while in cruise flight over the Pacific, and 2 passengers were seriously injured and later died. Intense concentration was required to prevent all kinds of undesirable effects on touchdown. One of the issues was that in order to reduce drag and increase fuel efficiency, it had an unusually small horizontal stabilizer. This would make the planes prone to wild changes in pitch, which were harder to counter due to the small pitch control surfaces. In 1999, Korean Air Cargo Flight 6316 went into a rapid descent when the pilot tried to adjust the altitude of the flight. They were not able to recover the plane, and all 3 occupants on board and 5 people on the ground were killed. So the MD-11 is not doing super well on safety records here, especially for a production run of about 200 aircraft. Also, like Nicole mentioned before, the landing speed for MD-11s, it's about 20 to 30 knots faster than comparable aircraft. So the MD-11 will land at 154 knots. Upon landing, the 1999 FedEx Express Flight 87 rolled down the entire runway before rolling into Subic Bay in the Philippines. Excessive approach and landing speeds were the probable causes in this incident.
So just going back to what we were talking about earlier about how they increased the landing speed on Flight 80 by 10 knots, this is kind of what I was referring to when I was saying, yes, it's only 10 knots more, but the MD-11s are already landing 20, 30 knots faster than other similar aircraft. And so when you add 10, now you're landing 30 to 40 knots faster than comparable aircraft, which on its own is probably not a contributing factor. Like we've seen with so many other failures we've discussed on this show, there usually isn't one cause or even one contributing factor. There's usually multiple things that compound each other that lead to these catastrophic events. And so the landing speed is just one piece of the puzzle here. I think had that been the only item, this probably wouldn't have happened. I mean, hindsight's 2020, but if that was the only issue, the plane probably would have landed okay. But when you factor in all of these other things that are going on with the MD-11s, it just adds to it's just another piece to the puzzle. So unrelated to this flight, but also another fun fact that I thought was interesting, the MD-11s had poor flame retardant properties from the metallized mylar insulation that allowed a fire to spread out of control mid-air. And this caused the 1998 Swissair Flight 111 to crash into the Atlantic Ocean near Halifax, Nova Scotia. The fire had started at the front of the aircraft from improper wiring of passenger entertainment systems added by the airline and quickly spread throughout the entire plane. And kind of as you've seen, we've built in all of these different examples to each of the different things that are going on with the MD-11 or each of the, we'll call them design flaws going on with this plane model. But as you can see, we've talked about a number of flights. I would say we're somewhere around 8 to 10 that we've talked about just in this episode alone, examples of issues with the MD-11 tying back to the design of the plane. And it's not really surprising to me that they only made 200 of these and they didn't last very long, and they're not used for a commercial flight outside of freight anymore.
Yeah, so overall, McDonnell Douglas tried to use software to correct the issues that we've talked about, but they weren't entirely successful in that software implementation. So after only 10 years of service, the MD-11 had an accident rate 15 times worse than similar airliners. I realize that there probably is some small sample bias in there with the accident rate, but there is a significant number of accidents that are tied to MD-11s. We've mentioned 5 or 6 of them here. If you only have 200 airplanes that you've produced, having 5 or 6 or more than that probably is not a good look for your airplane. So no one, from the engineers to the FAA, wanted to admit that they had designed, built, and sold a plane that was unstable. And really in the end, they didn't wind up having to do that, because by the 2000s, sales on the MD-11s were wrapping up in favor of Boeing's 777, and a few years after that, any MD-11s remaining in service were flying cargo and not passengers. The last operator of the MD-11 was KLM, the last operator passenger configured MD-11s, so KLM from the Netherlands was the last passenger operator of the MD-11.
One thing that I wanted to mention here, because we haven't really talked about that. So we're talking about the accident rate or the failure rate of these planes in comparison to how many were made. And these are catastrophic failures that are, almost all of them are unrecoverable. The plane never flies again. It's completely destroyed. These are fatal accidents. But I think it's important to think about also how, if these are the types of things that are going on with these planes, they must have been extremely uncomfortable to ride in as a passenger, even if you safely made it to your destination. There would have been a lot of what felt like turbulence on landing, and overall seems like unstable flight. And so I think these would have been rather unpleasant to be in, and I don't think I would want to fly in one of these.
So there you have it. FedEx Express Flight 80, a combination of lack of sleep, lack of landing experience, and the MD-11's troubled design led to a fatal crash that happened over a matter of seconds.
For photos, sources, and an episode summary from this week's episode, head to failurology.ca. If you're enjoying what you're hearing, please rate, review, and subscribe to Failurology so more people can find us. If you want to chat with us, our Twitter handle is @Failurology. You can email us at thefailurologypodcast@gmail.com. You can connect with us on LinkedIn, or you can message us on our Patreon page. Check out the show notes for links to all of these. Thanks everyone for listening, and tune into the next episode, another engineering marvel for episode 60. We're going to be talking about the Kicking Horse Spiral Tunnel train route over the Rocky Mountains. It's going to be an episode full of trains and mountains, including the news segment. Bye everyone. Talk soon.